Hi everyone. We finished the last course with some very cool games that you will be able to see on our website maybe in about a month or so. I cannot promise you a date, but they will be there and will be uploaded, and everything will be fine. You will be able to see them. They were all really good, and I hope that you can enjoy them. So on to the next one, and the final one in our academy is Unity and algorithms. This course is quite important, and some people may wonder why we've combined them this way. Well, Unity is probably gonna be the coolest for most of you. As an engine, as a way to make games and so on. It's relatively simple. There are many things that to make your work a lot easier than it was before when you're writing your code from scratch. So we combine Unity as the coolest thing in our course with algorithms, which is going to be the hardest thing in our course. And we left it out for the end because Unity needs a bit more knowledge, which you already have, and the algorithms are something really essential when you are developer, especially game dev. But we'll get onto that. So hooray, we are going to be going back to C# and Visual Studio. For those of you that did not enjoy the JavaScript in general, we are going back to the origins of the first two courses. All right. So short lecture, as always. We'll see who is gonna lecture these. Then we'll see what we are gonna study, evaluation, timeline, and then that'll be it. Relatively quick. You all know me. I've been teaching for the past 8 months now, so I'm not gonna spend too much time here. The person who is gonna teach you Unity is Stamen. He's a really cool guy. And he's a Unity ninja, and if you need to ask him anything about SDKs, integration and stuff, he's the god of SDKs. So if you need something, something for your own project or something, he will be able to help you. Most of the projects that he manages are in Unity, so I'm sure that you will learn a lot from him, and make sure to ask him a lot of questions when we start with the Unity lectures. One thing that I should mention, the Unity lectures are not going to be in English, but I will try in the near future to translate them somehow, either via audio overlay or something, to try and translate them into English. But for those of you who are in the room now, that will not matter that much. Okay. So lectures overview. So this is in two parts, which are I would say very unrelated, because one of these is this hard abstract thing with solving mathematical sort of problems with computers and C#, and the other one is just making games with Unity. Again, I decided to combine these because otherwise they would have to be two separate courses. Each of them would be very long, and I think this will be pretty much enough to get a bit of both worlds, and it's not going to be an infinite course where I said something like 9 months or something and extend it over a year or something will not be that good. Actually, what did I say at the beginning? Did I say 6 months? 6 months. So we are now in the 8th. I'm not doing that bad, okay? So yeah, could have been longer. All right, so data structures and algorithms is the first part. So this first lecture should have been outside, because we're not going to be doing anything special today. So the first official one is going to be data structures. It's going to be very long, or maybe in two parts if I don't have enough time, but I think I'll be able to manage. So we'll look at first linear data structures, and I'm sure that you've heard those and we've used some of them in some of our games and demos and so on. So array, you know what that is. Very briefly I'll mention what that is. List, linked list, you haven't heard of that one, but it's it's another approach to making a list, I would say. Then we have queues and stacks. We've used queue for our snake game in the very first course. It's nothing special. And I would like to say, if you don't like the words, queue and stack, and when you hear them and someone tells you, well, you can simply implement that with a stack or a queue, and you wonder why, or this is too complicated or something, you can always substitute these two with a simple list. I would like to say. Just sometimes, the list has a lot more things in it, and some of the things you wouldn't need for the specific case, and that's why we have queues and stacks. But right now, if you just use lists wherever you want or need for that kind of structure, it will be absolutely fine. Trees and graphs. All right. So I've put a star here, which means that I'm just gonna give you a link to a previous lecture in the second course. It was a workshop on graph theory, which was very detailed, and in fact it's one of my most favorite lectures in the whole course. So I'll be sure to give you a link below to that lecture if you can't find it. And also I'm not going to spend too much time on graphs because the lecture that you've already had was pretty extensive, I think. So yeah, I'll briefly mention trees, and as a part of your homework you will have to implement a tree structure similar to the graph one, but since trees are simpler, you wouldn't have to worry that much about how long is it going to be. It's not going to be that long. It's just a good exercise on data structures. Then we have dictionaries, hash tables, and other data structures. So for the dictionary and hash tables, I will briefly mention and explain what they are. I'll spend the most time probably on dictionaries. And then other data structures that you may never see again ever in your life, I'll also mention, but very, very briefly without going into any details. I'll just put them there as a reference. If you need something very, very special, you can just come back to the presentation of the lecture and see, well, I can use this one. It will be like a quick table or something where it says, what is the data structure and where you can use it, and also what can you substitute it with. But these are not that complicated. I mean, you've seen a lot of things during the course, so I doubt that anyone is going to have problem with the data structures here. Furthermore, all of them are implemented in .NET, so feel free to just use them and never again look at how they're implemented. Just use them. That was the abstraction principle that we were talking about in one of the previous courses. All right, so data structures are fine. They're relatively easy. I would say nothing that complicated. Maybe there are some complicated stuff with trees and graphs, but we wouldn't go into that much detail on those. But the most important thing is how and where to use them. And here comes algorithms, complexity. Then we'll look at sorting algorithms. That will be very, very brief, since you had in your homeworks you had to write I think merge sort, quick sort, selection sort in the first course even. Did I give you anything else? Bubble sort or something? No one remembers. Okay, maybe for this specific lecture I would ask you to write some algorithm, some sorting algorithm that you haven't done. So something like shell or bubble sort. Bubble sort is too easy, so probably shells. Sorry? Merge sort, you had it in your homework. Selection and quick sort. I am gonna check that, but I trust you since you're very, very confident. But I'll have to check that. Okay. So maybe I'll give you two then merge sort and the other one. But merge sort uses something in the next lecture, so probably leave it there. I think recursion. Yes. The next one will be recursion and combinatorial algorithms, and recursion is always not easy to explain and understand. I will really try my best to explain it in the best way possible, because if you get it now, it will be very, very good and impressive in the future when you can just sit down and type in a simple recursion without having to remind yourself what that is. And it's not even that complicated. It's just it works differently from the code that you normally write, and that's something that makes it a bit more weird. I would say. I wouldn't even say complicated. Then we'll see dynamic programming, which is something that is sort of like clever math solutions to problems that normally you would like to solve with recursion. So has anyone heard or used in code dynamic programming ever? It is really cool, and you will see what that's about. So I think lecture number 5 will be mostly a couple of demos where you can use it, which are very, very common. But yeah, it's not that complicated. In fact, it's very, very clever, and kind of makes my point that math is kind of important when it comes down to programming, especially game dev. All right, then comes the Unity part, and the first lecture is going to be Unity overview. You can find tons of those on the internet, but we'll try to make it, I don't know, I wouldn't say better, just because there are millions of them out there. Well, not millions, but I think I've seen at least 100 lectures which are the same. So we'll try to make something a bit more interesting there. Okay, 7 and 8, making a 2D game with Unity. So you're now used to 2D games, and I thought it would be really good as a reference. How would you make a 2D game in Phaser, which is something that you already know, and monogame as well, and how would you make it in Unity? And I would really like to say that it's easier, but depends on the game. So a game with a specific title, you may be able to make in Phaser a lot quicker than with Unity. On the other hand, some game are totally impossible to make in HTML5 game engine, whatever that is. So yeah, Unity has definitely developed there. A couple of years ago, or at least 2 or 3 years ago, the 2D instruments were very poor, and it was really hard. So you had to make a 3D game. Sorry, you had to make a 2D game inside a 3D game engine, which was always kind of hard. But now I think the tools are very, very good, and you'll see that making a 2D game is not that hard. And then instead of making a massive 3D game, which is not going to make that much sense, we are just going to have a couple of 3D demos. So parts of a game which we have not decided yet on, but maybe how would you approach a first-person shooter game where you have to jump, see your weapon in front of you, aim, shoot, stuff like that, but not making a complete level or a complete game where you can shoot other people. Just some approaches to standard game titles that are out there, or standard like game genres. I think the other one could be a racing game. So how would you manipulate the camera there? We have not yet decided on those, but I'm sure that we'll make them fairly different, and you will be able to enrich your knowledge on how to create 3D games, or at least how to approach them. How does that sound as an idea? Instead of making a massive game, just show you how to start, with a couple of different paths that you can take with your genre. Okay. Workshops. Compulsory workshops in data structures. So, and algorithms, So the idea here is that, and I said that earlier, but it was not on video, what separates a good developer from just a developer, especially with gaming, is your knowledge of algorithms on the one hand, and the other one is architecture, as the colleague here said, architecture, quality code, structure, and so on. But really, algorithms are quite important, especially with game dev. So even the simplest games sometimes require, a lot of complicated algorithms, I would say. So right now we are making a very, weird kind of Tetris in fractal games, and I really thought that it would be quite easy to implement. And then it turns out that for the special case of our Tetris, there were some really nasty algorithms there. But yeah, so you can meet it in any game, independently of how easy or hard it is. So yeah, these ones I would say are compulsory, where we would just discuss the homeworks, how you've done it or you haven't done them, and really try to engage, and I'll try to help you as much as I can with those. But it's quite crucial that you get the first part. The second part, Unity, there are plenty of courses out there, plenty of tutorials, even official ones. So if you want to, you can always get into that. But if you don't understand algorithms, you may be stuck, in your own comfort area, where you can do, either some simple games, or you make workarounds, which are not often the best. And sometimes in games, performance is really crucial, as you may have seen with Phaser, which sometimes if you put like too many sprites or too large sprite sheets and stuff, it just doesn't work properly, and it lags and so on. Here these kinds of problems are not there, but you can always very, very easily make some kind of a weird loop or a weird algorithm which looks very, very easy to you, and then the game hangs while it tries to compute what you want to have. So yeah, algorithms are important, is my point. If you want to, and only if you do, I can make an additional workshop for mathematics in computer games. What do you normally need to use, what I've stumbled upon with our project, which actually makes mathematical games. So you would expect some algorithms there, and I can make a lecture about that, but that's only if you want. And then Unity workshops, I'm not sure whether Stamon will be available for those. But if there is anything that I can help with, I'll be happy to have those as well if you want. But what is for sure is the first one. I think starting from next week, next Saturday, or if you want to some other day, we are gonna have workshops on data structures and algorithms, because I want to make really good developers and not just some random ones. All right. Any questions, suggestions here? Is there anything else that you would like to see, or we're all good? How does it sound? Or the only thing that you can think of is C sharp. C sharp is exciting. Yeah, I guess so. But yeah, any comments? Everything fine? Good. Okay, the course will be evaluated as follows, and 10% attendance for the first time in our academy, because you are now here and you've reached this part. I didn't really care at the beginning. There were all kinds of people that were not really serious about what they were doing here. But right now it's really, really crucial that you visit at least the first part of the course. Again, I really would like to make you, very confident about your algorithmic knowledge, and that will come mostly not from the lectures, but probably from the homeworks and the workshops. So yeah, I strongly advise you to do that as well. This is subject to change. I can make it 10 attendance and 10 homework, but then again I'll have to check your homeworks, and I'm not sure that I'll have the time for it. We'll see. I'm not sure, but I really want to make you very eager to learn what you're about to learn, because it's I think at least very crucial for a game dev. And then you have the teamwork project, which is not going to be as concise as the previous one. So in the previous one, you had to do a lot of things. So detailed GDD, tutorial, marketing, monetization strategies, and so on. This will not be in this course because you've already went through it, so you already have a more broad idea of how game development works and how an idea comes to life and what's behind it being successful. Here it's a simple idea. Use Unity to make a cool, unique game, and then just briefly describe it in a couple of pages so that we can see something, not just the game. Right. I really would like to stress this time on unique, because we'll be making a very specific 2D game, and I don't want to see people doing the same thing. For the 3D demos, if someone decides to make a 3D game, then feel free to start with the demos and go on from there. But 2D games, if you make those completely different, please, from what we've already done in the Academy. So that includes, I would say, platformers. So yeah, platformers are fine, even though we've made one in the last course. Platformers are fine as long as you make them really cool and amazing. Okay, I would say that. If you have to copy an idea, just try to make it as cool as possible. All right. Timeline. So this never goes right. But let's say that we'll try our best. So lectures from 16th of November, which is Monday, according to my calendar, or at least what I thought earlier would be Monday. Yeah, so from the 16th to the 18th of December. And that I've calculated based on the lectures that I have. I'll only be lecturing half of the course, and the other half will be from someone else, but the plan is to finish by the end of the year, give you some time to rest and so on, make your projects, have a nice Christmas and New Year, and after that, in one of the first weeks of January, we'll be doing the evaluation, and a couple of days after that, it will be the official closing of the first season of the Academy with a party and certificates and food and drinks and stuff like that. Sorry, strippers. That's a cool idea. I'll make sure to mention it, for the people in charge. Strippers, cool. Right. Then again, Monday and Thursday from 6:30 to about 10-ish. Again, this course, the lectures are gonna be longer, probably. Bear that in mind. We may once finish at 10. For once in this whole course, we may have to finish at 10 o'clock. But other than that, I think you will be fine. You're now used to long lectures, I hope. Okay, right. I think that was it. Do you have any questions? Apart from the teamwork, which I'll talk about, since it doesn't concern the people watching online, I'll talk about that in a minute. Any questions about the course? Suggestions, if you have, now is the time to speak. But yeah. We have an OCD person in the room. Okay, right, so that's all, and I'll see you on Monday then.